Hey guys, we are going to be in our packets and our workbooks today. Um, Sorry I can't be there with you, but I wanted to just kind of walk through this. This is actually all review. We're just understanding ratios and looking at a little bit of equivalency, remembering whatever we do to one, we have to do to the other. So this is just walking you through essentially the first part of your notes in your packet and how we understood them. So one way is a bar diagram to compare. Another way, they're talking about using ratios. All right, so this is jumping to page 4. So a ratio, remember, is a comparison between any two quantities, right? In which for every so many units of one, there are so many of the other. So here we have 10 full cups of lemonade, and for every 10 cups within that are 2 cups of lemon juice. So if we wanted to make 2 batches or 20 cups, to make 20 cups, we would multiply that 10 by 2, right? So that's exactly what we do to the amount of lemon juice. Whatever we do to one, remember we do to the other. And this is going to be very beneficial for you as we're looking at ratios, we're looking at recipes. You're going to be doing a task that has to do with ratios and recipes. Is great in time for this holiday cooking that hopefully you will help out in your kitchens. So to make 3 batches, again, they're multiplying everything by 3. So now we have 6 cups of lemon juice for 30 full cups. All right, so these are all the same. They're all equivalent because we're multiplying by the same thing. So in this example 1 on page 5, Pedro is mixing paint. He has 2 containers of blue paint with 3 containers of yellow. So all of a sudden he realized he didn't have enough, so he added 2 more containers of each color. When we add to both, the question is, will the new mixture result in the same shade? What are your thoughts? So some of you might be thinking, wait, we talked about multiplying and dividing, not adding, and you are so right. So if he added 2 to the blue paint for a total of 4, that's like doubling that. So did he double this when he added 2? No, 3 didn't go to 6, it went to 5. So you're right, these ratios are not correct. But if Pedro adds 1 more container of yellow paint, now he has that same ratio of 4 to 6, which is equivalent or equal to 2 to 3. So now as we're thinking about this, if a recipe for rice calls for 6 cups of water to 3 cups of uncooked rice, does that, and she only has 2 cups of rice, sometimes I like to label these, so water and rice maybe, that way I know I'm putting the rice, the 2 on the bottom where the rice is over here. She reasons that because she subtracted 1 here to get this, she could just subtract 1 here to get 5 cups of water. Are these equivalent? Well, one thing we were learning about is if we simplified these ratios to their simplest form, right? If we divided both of these by 3, we would have 2 to 1. Then this does not equal this. We can't simplify this any further. So we know that these do not equal. And so I'm just going to show that. That's going to be my explanation. I'm a math person. I don't like a ton of words. I like to show it with my problems, okay? So now we're just kind of learning how to write those ratios. That's what we did at the very beginning of our packets, right? We were writing ratios. So we wrote them in, right? Part to part, part to whole, whole to part, in 3 different ways. And you'll see that is the same here, right? So this is just learning about part to whole and part to part. So if you didn't pay attention those days, even if you did, this will help you master that. A part to whole ratio compares 1 part of a group to the whole group. 1 part to the whole group. So this was like our lemon juice to the whole of the lemonade, right? So for every 2 cups of lemon juice, it made a total of 10 cups of lemonade. So part to whole, part to whole, part to whole. And you see the 3 different ways to write it. Now, part to part ratio compares 1 part of a group to another part of the same group. So here they're comparing lemon juice to water, which kind of takes out just 1 of the other parts, which was the simple syrup. And you can see that this is a bit smaller. Total, it's only 9 of the 10, right? But what's important is that you can write it in multiple different ways. They're saying that we don't usually use part to part as a ratio, but we've been using that, I'm sorry, as a fraction. But we've been using them as fractions because it helps us transfer those simplifying fraction skills back to simplifying ratios, okay? So let's look at example 2. So I think you'll like this. This is what we've been doing with our tables already. If we're maintaining these ratios, whatever we do to one, we have to do to the other, right? So here is the small vase quantity. A florist is arranging flowers in vases. She has 2 sizes, small and large. She wants the large vase to have the same ratio. So I'm just going to make another column for my large just to help me here. But we don't know. If the large vase has a total of 36, that's all we know about the largest so far as its total. We don't even know that about the small, but we can figure out how many tulips there are, right? Because we just have to do a little math to figure out our total here. So 6 plus 2, good, 8. 8 plus 4, excellent, is 12. So if we want to know how many tulips, right, we're going from left to right, from small to large, what did we have to do from small to large here? Good, we're multiplying by 3. So that's what we'll do here, times 3. So we could extend this table to check our work, right? Times 3, times 3, times 3. These are ones you should know, but if you're struggling with your multiplication, grab that multiplication table, be working on those at home, right? I know 18 plus 12 is 30, plus that 6 makes 36, so that checks. So that's our answer, right? How many tulips? 12 tulips. So right here, 12 tulips, 4 times 3. They showed you this in a diagram. Was it necessary? Maybe. It might be helpful for you. Do you see how they first fix these to make 36? And then how many tulips was that? If there are 4 parts, 4 times 3, okay? So if we're looking at that same example, how many carnations are there? We figured that out already. If we had to multiply the total by 3, we had to multiply the part by 3. So 6 times 3 is 18 carnations. All right, so kind of what we've already been doing. Again, this should be review, but it's helpful to be retaught things in different ways and at different times. Hopefully you're paying more attention now. All right, now we have part to part, but it's the same concept, right? We're looking at muffins, small and large boxes again, like the small and large vases. The manager wants to maintain that ratio in the large and the small. So if the large box contains 9 chocolate, I'm going to make another column here. There's a 9 there. How many blueberry muffins? So I want to know how many blueberry muffins are in this box. So I'm trying to figure out, what do I do to the 2 to get my large quantity? Well, what did I do to my 3 to get my large quantity? If you're not sure, you could think 9 divided by 3, right? So we had to multiply that 3 by 3 to get 9. So 2 times 3 gives us 6. So there are 6 blueberry muffins in the large box, right? So now, if I refer to this table, if the large box contains 9, how many cinnamon muffins are there? So whatever I did to one, I have to do to the other. So 1 times 3, you know, is 3. Good job, Polly. So 3 cinnamon muffins goes here. 3 cinnamon are in the large box. All right, so that is it. That's all of our examples and our checks in the workbook today. You just have to apply this now. These first questions are just asking you to write ratios. Sometimes you might have to add. So this one, in fact, is a part, the number of posters, to a whole, the total prizes. So I do have to do some adding here, but I'm going to write my posters first. 11 to a total number. 5 plus 1 is 6 plus 7 makes 13. 1 plus 1 plus 1 is 3. So 11 to 33. Now, since you are all bright and brilliant, you probably know how we could simplify this. You do not have to on these questions, okay? But I'm just kind of refreshing your skills. What could I divide these both by to simplify it? Well, 11 can only be divided by 1 and itself. So that's where I would start. Can I divide 33 by 11? Of course. So 11 divided by 11 is 1. And 33 divided by 11 is 3. So that could be simplified, but this is completely acceptable, right? Now, here we are. Ratio airplanes to stuffed animals should be super quick, right? Airplanes. 2 stuffed animals, 7, 2, 15. El Dunzo, right? This was all on page 11. Make sure you are with us. This was the next page in your packet. I know you got this page done with Ms. Boots on Friday. All right, so page 12, 13, 14, 15, 16, 17. You don't have to do all of them today, but we're going to get a good start, okay? So again, I'm going to have you come back. Try number 3 on page 12. What did you say here for the ratio of stuffed animals to posters? Again, this one is not simplifiable, so you could just write 15 to 11. Make sure whatever they have listed first, that's the number you list first. And whatever they have listed second, that's the number you list second. Or top and bottom, right? Whatever's first goes on the top. Whatever second goes on the bottom, okay? I know we've practiced a lot of that. All right, this looks like a lot of words, but I promise it's okay. It's saying, this is just like the blue paint, yellow paint one. She's got 6 dimes and 4 quarters. Her friend has 5 dimes and 3 quarters. But Siri thinks that since they're the same because they each have 2 more quarters than dimes. But as we look at it, in the way we have been taught 6 to 4 and 5 to 3, we know to test for equivalency by simplifying. So if I simplified this, these are both even, so I'm dividing by 2. I got 3 to 2. This can't be simplified any further. I can't divide 5 and 3 by the same number. So these are not equal. So is the ratio of dimes to quarters maintained? We would say no, absolutely not. And then they're just asking for series ratio, right? Which was, well, I guess you could say 4 to 2. No, you can't. They want it in this form. 6 to 4, so 6 to 4. And Martha's ratio was 5 to 3. So 6 to 4 and 5 to 3. So that really quickly wraps up page number 12 in your packet. So 5 is just like that. 6 is one that we might want to look at. This one looks like the ones when we're trying to figure out the unknown, right? Riley's making fruit punch. Maybe he's making it for Thanksgiving. So let's see, 1 batch. Here is the ratio for 1 batch. If the punch bowl holds 27 cups, So we're talking total here. So I don't have a list for that, but I'm going to add that in. I'm going to leave a blank here because I don't know what our individual one batch total cup is, but we can see how many cups we need now because we can come up with this total. We can add, right? 4 plus 1 is 5, 6, 7, 8, 9. So if we have 9 total cups in this original ratio, we're just figuring out what we did to it to make 27. You got it. We multiplied by 3. So that's what we need to do to the orange juice. What is 2 times 3? Good. 6 cups. That's it. So those similar questions you will find on page 14 and 15 as well. Let's just look at one more on 14. I know you need to come back to page 13, but the other way they might show you is just in word form, and I really want to model that for you. So as I'm reading, I'm going to start writing some things down, just with little labels to help me, okay? So Mrs. Santiago is buying donuts. Each box contains 6 glazed, so I'm just writing 6G, 4 cream filled, CF, and 2 chocolate, so 2CH. How many chocolate donuts did she buy if there were 20 cream filled? So if I want to know how many chocolates, I'm going from left to right. What do I do from this left to make this right? I'm not adding. Remember, I have to multiply by something. Good. So I'm multiplying by 5. 2 times 5 gives me 10. Do you see where that 10 comes from? So again, just go through and write it. This has a ton of ingredients. So I'm going to kind of 2 cups of raisins, 2 of peanuts, 1 cup of sunflowers, and 1 cup of chocolate candies. I think it's M&Ms, right? But if the large batch is the same, if there's 8 cups of peanuts, again, how many sunflower seeds are there? So I'm trying to figure out what this is. Remember, again, I can't just add. I have to multiply the 2 by something. What did I multiply the 2 by to get 8? Good. So 4 times 1 is 4. So we need 4 cups of sunflower seeds. Do you see how that works and see how you'll use that in real life? All right, so you've got lots of time. Hopefully you can get through page 17, but we'll have some work time towards the end of these sessions for you to go back and review those things as well too. All right, so that wraps up 1-1.